All right, we're keeping up with the geometry. So we did triangles in the last video, used some algebra to solve some problems relating to triangles. And now we're going to look at quadrilaterals. All right, the main quadrilateral everyone should be familiar with is the square, right? Where every single side has the same length. So if this is 4, that's going to be 4, that's going to be 4, that's going to be 4. And all the angles on the inside of the square are each 90 degrees. Following the square, you may have been introduced to the rectangle, the oh-so-famous rectangle. Very similar to the square, but instead of all 4 sides being equal to each other, the sides opposite of each other are equal to each other. So we use those tick marks again. And then just like the square, the angles inside of a rectangle are each 90 degrees. The last quadrilateral I want to go over is the parallelogram. And there are more quadrilaterals than these 3, but I just wanted to do a quick intro. Don't want to go too deep into it. But a parallelogram is a lot like a rectangle, but it's just been slanted one way. So sides opposite are equal to each other, and then these 2 as well. And then angles opposite to each other are equal to each other. So these 2 angles are the same measure, and then these 2 angles are the same measure. So let's condense it down to a few key points. So quadrilaterals, they have 4 sides. That's it. No more, no less. All quadrilaterals have 4 sides. Right? The sides in these quadrilaterals are parallel. Now, not all quadrilaterals have sides that are parallel to each other, because if I drew a 4-sided shape like this, right, those sides are not parallel to each other. But the 3 that we have here, right, this side's parallel to that side, this side's parallel to that side, this side is parallel to that side, so on and so forth. So that's why I put a little asterisk here. As long as the quadrilateral you're looking at is a parallelogram, because squares and rectangles are parallelograms, then the sides are going to be parallel. The angles in a quadrilateral add up to 360. This is true regardless of what it looks like, whether the sides are parallel or not. So if you add up all of the angles in a rectangle, or all of the angles in a parallelogram, or all of the angles in a square, you're going to get 360 degrees. All right, and the last thing, the area of a quadrilateral, and specifically these 3, the parallelogram, rectangle, square, is going to be base times height, or length times width for rectangle and square. It means the same thing. So for the square, our base, right, we could call that our base, and then the height would just be one of the sides of it. So base times height is going to give us the area there. Rectangle, same thing. You could call this bottom side my base, and then the height could be over here. For the parallelogram, base is still at the bottom, but remember the height is a straight vertical line going from the base up to the highest point there. So that's going to be our height that we would use to find the area of that parallelogram. All right, first example, we got a rectangle here. The perimeter is 44 centimeters, and we want to figure out what the dimensions of this rectangle are. So what is the width and what is the length? We're given expressions here, but I'm first going to notice that, so we are dealing with a rectangle. So that means opposite sides of rectangles are equal to each other. So that means this is going to be w plus 6, and that is going to be w. So if I add all those sides up together, I'm going to have the perimeter. So if I were to write this like w plus 6 plus w plus 6 plus w, well, that's going to be equal to the perimeter, which is equal to 44 centimeters. Okay, so now this just becomes an algebra problem. Combine your like terms and solve for the variable. So I got w plus a w plus a w plus a w. That's 4 w's. And then I have plus 6 and then plus 6. So it's going to give us plus 12 is equal to 44. If I subtract 12 from both sides, I'll get 4w is equal to 36. If I divide both sides by 4 to get w by itself, I'll have w is equal to 9. All right, so that's the width, it looks like over here. All right, so w is equal to 9. I should put centimeters because we're dealing in units. And then the length, right, is just equal to w plus 6. So what's 9 plus 6 is 15. That's going to be 15 centimeters. So there's your dimensions for this rectangle. All right, here we got a quadrilateral. It doesn't look like a square, it doesn't look like a rectangle, it doesn't look like a parallelogram, but that's okay, because for this problem, we're just solving for x and then for each angle in the quadrilateral. And we said that if you add up all the angles inside of a quadrilateral, you're going to get 360. So let me set that up. So we're going to go 2x minus 17 plus 59 plus x plus, what is that? Well, that's 90 degrees. So plus 90 is equal to 360. I'll combine my like terms. I got a 2x and an x. That's going to give me 3x. And then I have minus 17 plus 59 plus 90 is equal to 360. If I combine all those together, and I'll break out calculator because I don't want to do that in my head, it's going to be 132. So we got 3x plus 132 is equal to 360. I'll subtract 132 from both sides. We'll get 3x is equal to 360 minus 132. That's going to be 228. And then divide both sides by 3. So we'll have x is equal to 76. So that means this angle over here, that's 76 degrees. This one stays at 59. If I plug 76 into the x there, I'll get 2 times 76 minus 17. And this one's going to be 135 degrees. And then we have the 90 over there. So there are our 4 angles. Easy enough. All right, here for these two, we are solving for the area. So remember, the area is equal to base times height, right? And we're given that. We're given our base here and then the height there. So this is super easy. The area is going to equal 11 times 5. So the area is equal to 55 inches squared. Don't forget units when you have them in a problem. Okay, here for this last one, we're given the area. So we want to figure out what the base is. We're given the area and the height. So again, just start with your formula. Area is equal to base times height. Well, what do we know? Well, we know the area is 105.45, so I'm going to plug that in for A. So 105.45 is equal to the base, which we still don't know, so B, and then the height is 11.4. So one-step equation, right? I'm going to divide both sides by 11.4. And then 105.45 divided by 11.4 is going to give us B is equal to 9.25 centimeters. So there it is.